So when we look at the law of conservation of matter, okay, conservation of matter, when something is conserved, okay, what does that mean? Conservation, what does that mean? To keep. So the law of conservation of matter states that matter can neither be created nor destroyed. You can't make matter out of nothing, and you cannot get rid of it. Matter can only change from one substance to another. Okay, you're always going to have the same matter. It just might not look like it did at the beginning of your reaction. Okay? And when we talk about matter in a numerical sense, whatever elements you started with in your reaction and the number of atoms that you started with, you will have that exact same number of atoms and the exact same kinds of elements, but they may be rearranged to form new types of molecules. So when we look at a chemical equation, okay, because when we're trying to show a chemical reaction, we want to say what we started with, the reaction occurs, what we end up with. And those actual concepts, they have names in a chemical equation. Okay? I'm going to use the example of the formation of a precipitate that we just wrote on the board. All right? I'm going to use the example of sodium carbonate plus calcium chloride yields sodium chloride plus calcium carbonate. So here we have an actual chemical reaction. This is the formation of the precipitate that we just looked at. This is when you mix two clear-looking liquids, okay, sodium carbonate, NaCO3, and you mix it with calcium chloride, CaCl2, all right? And we saw that when you combine those two clear liquids, you get this milky, sort of chalky-looking substance, okay? And what ends up happening here is the reactants on one side react together to create this chemical change, and they form new products. So every time we look at an actual chemical equation, we've got to divide it into two. Okay? The things on the left side of the equation, the substances on the left side of the equation, what you start out with, these are always referred to as reactants. Okay? And you can have just one reactant. You can have 5 reactants. It doesn't matter how many reactants you have. And the stuff on, so the arrow sign here, in chemistry speak, the arrow sign means yields. Okay? In math speak, the same symbol exists, but you know it as equals. It means the same thing. When you add number 1 and number 2 together, you're going to get number 3 and number 4. Okay? Substance number 3 and substance number 4. So if the reactants are on the left side of the equation, then on the right side of the equation, we have what's known as products. Just like in multiplication, when you multiply two terms together, the answer is their product. Okay? Well, when you have substances react to one another, they create something new, they produce something new. That production, okay, the production of that new substance or those new substances is known as collectively products. All right? Now, here's the cool part. Here is the part where we abide by the law of conservation of matter. The different types of elements on one side are going to show up on the other side. And what I mean by that is, can you tell me what the elements are on this side of the equation, on the reactant side? Okay, so before we actually look at whether or not the law of conservation of matter is abided by here, or we are abiding by it, we have to understand how we actually make these chemical compounds, these molecules. When I read this, how do I know that this guy right here has both sodium and chlorine in it? Yes?
Well, in the beginning of each element, there's a capital letter, and then there's lowercase letters.
Okay, that is amazing. That is bang on. At the beginning of each element, okay, we have a capital letter. And you will notice that some elements only have one letter. And if that's the case, that letter is capitalized. But if another element starts with the same first letter, well, if we have one element that is just C, that's carbon, well then calcium also starts with a C, but we can't just put a C there because that's already taken. So if there's ever a lowercase letter after a capitalized one, in the case of CA, CA is one thing. The lowercase letter belongs to that element. Okay? And we know that a new element starts with the addition of another capital letter. So in the case of NaCl, okay, and this I'm going to actually remind myself to draw my L's like so, because I is also an element on the periodic table, and I don't want anyone getting confused. Okay? So here I've got a big N and a little a. Does the A belong to the N or is it on its own? It belongs to the A, or it belongs to the N, sorry. So if we look on a periodic table of elements, which you have in your textbook and you will get used to reading, we would look for this symbol and we would see that it is sodium. Na is the symbol for sodium. Now, if we look for a big C, now would this little L belong to the C or is it on its own? Belongs to the C. So how many elements are in this molecule? There are 2 elements in this molecule. 1, 2. Now, let's complicate things a little bit here. Let's look at this big guy. Okay? First of all, C, does the A belong to the C or is it on its own? We've seen this guy before. This is calcium. Okay? So there is one element right here. One element in this molecule. Now, the next 2 we look at, there's a capital C and a capital O. Therefore, how many elements are those? Those are 2 elements, even though they're combined together. Okay, in this case. And we'll get to the combining later. Don't worry about it. But here we've got a C and we've got an O. So on this side, on the product side of the actual equation, how many different types of elements do we have? So on the product side, we've got a total of 5 different types of elements. Okay, we've got Na, we've got Cl, we've got Ca, we've got C, and we've got O. Let's look at the reactant side. Okay, how many elements do we have? Do we have an Na on the reactant side? Yep, right here. Do we have a C on the reactant side? We sure do. What about a Ca? Do we have one of those? Over here. What about an O? Right here. What about a Cl? So the law of conservation of matter tells us that the elements that are part of the reactants must also appear in the products. They don't have to appear in the same formation, but they must be there somewhere. And they are in this equation. Okay, the next thing we're going to talk about, and we'll talk about it later, is the number of atoms. I don't want to get into that today, okay, or in this video. I do want to talk about actual word equations versus chemical equations, because this right here is an example of a chemical equation, because I've used the chemical symbols for the elements. If I wanted to write this word equation, and I don't expect you to memorize these, okay, I don't expect you to know offhand. You're going to learn how to name some things later, because there are some tricks to it, but right now, we could easily make a word equation of this. Does anybody remember what this first reactant is called? Sodium, and what is this guy right here? Anybody remember? This is a tricky one. Carbon. Close. Carbonate. So the word equation for this would be sodium carbonate plus, what is this guy called? Ca. What's Ca? Calcium. And what's the last one? Chlorine. But when we combine them, it's going to get changed to calcium chloride. Now, and this is going to yield, what is NaCl? Sodium chloride. So this yields sodium chloride plus, what's this guy? Yep, say it. Calcium carbonate. Calcium carbonate. So here we've got two different types of equations. Okay? If ever I ask you to make a word equation of something, you will have the actual words there and they will already be spelt out for you. You will just have to put them in the proper order. You will have to put the reactants on the reactant side of the equation and the products on the product side. Okay? And if I give you the words and I give you the symbols of these molecules, I expect you to be able to create a proper chemical equation. That means put the reactants on the side, and you could easily put CaCl2 first and NaCO3 second. You could easily do that. It doesn't matter which one's first or second. What matters is that they are on the right side of the equation. Reactants must be on the left, products must be on the right.